So for number 77, we want to determine whether the sequence here is increasing, decreasing, or not monotonic. Not monotonic just means that it alternates between increasing and decreasing. Okay, so we have that an is equal to n over n squared plus 1. Okay, and so over here, we're going to determine the behavior of this sequence using the function y is equal to x over x squared plus 1. And the reason that we can do this is because the function and the sequence are basically the same thing, but the only difference is that the function is continuous and the sequence is only defined for natural numbers. But either way, they behave the same way, generally speaking, right? So if y is increasing, a of n is also increasing. If y is decreasing, so is a of n, and so on and so forth. So we're going to analyze this function here, and the way that we're going to analyze whether it is increasing or decreasing is through the first derivative test. So the first derivative test, it means that if we take the derivative, we can see how the function is growing, right? Because the derivative is about growth. So if the derivative is positive, it means that the growth is positive, so it's getting bigger. And if the derivative is negative, it means that the growth is getting negative, so it's getting smaller, decreasing, right? And so we're going to go that y prime is equal to, let's see, the one below squared, so that's squared. And then the lower one times the derivative of the first, which is just 1, and then minus the upper one, so minus x times the derivative of the lower, which is 2x. And so this is going to be, let's see, x squared plus 1, so that's going to be x squared plus 1, and then minus 2x squared over x squared, it should have been squared here, plus 1 squared. And so this is going to give us, let's see, that's going to give us 1 minus x squared divided by x squared plus 1 squared. Okay, so the bottom is always going to be positive, right? Because it's whatever the input squared. So the bottom is always positive. So we have to ask ourselves, when is the top part going to be negative, right? And so to ask ourselves that, we have to find the critical point. Which is, when does this turn around? When does it go from negative to positive? So we're going to set it equal to 0 to find the critical point. And so 1 is equal to x squared, and therefore x is equal to minus 1 and positive 1. So what we're going to do here is we're going to test our critical points here. Points at x is equal to negative 1 and x is equal to positive 1. So what we're going to do here is we're going to test our derivative and see whether it's negative between these 2 points. So we have negative 1 and a positive 1. So I'm going to choose a number beyond 1, so maybe 2. If I choose 2, I'm going to have 1 minus 2 squared, so that's going to be 1 minus 4 divided by 2 squared plus 1. So 4 plus 1, 5 squared, so that's 25. So this is going to be minus 3 over 25, that is negative. Let's choose a number between them. Let's choose 0. So if I put 0 here, I'm going to check my derivative. So 1 minus 0 divided by 0 plus 1, that is going to be 1, so that is positive. And let's check before negative 1, right? So before negative 1, maybe we're going to do negative 2. So 1 minus negative 2 squared divided by negative 2 squared plus 1 squared. And so this is going to be 1 minus negative 2 squared is 4. So 1 minus 4, negative 3 over negative 2 squared is 4 plus 1, 5 squared. Same thing, negative 3 over 25. So that's minus. So we can see here that y prime is greater than 0 when then let me just move this around. Okay, so say that y prime is greater than 0 when x is between negative 1 and 1, right? So when x is less than 1, which is greater than negative 1, and y prime is less than 0 when x is x is less than negative 1, greater than minus infinity, or when x is going to be greater than 1, right? And so, actually, this is not correct. I should say when x is less than -1, yeah. Okay, so once we find this, we can now compare it with our sequence. Well, our sequence, since n is only evaluated from 1, 2, 3, 4, 5, and so on, it's never going to fill this scenario here, right? It is never going to be less than -1, and also it is never going to be between 1 and -1, because it's never going to be less than 1, right? So it can be at most +1. So +1, 2, 3. So it is also never going to be in the scenario. So the only scenario that fits our sequence is when x is greater than 1, right? And we have seen that when x is greater than 1, our derivative is going to be negative. So we can say that when x is greater than 1, the derivative is negative. So when n is greater than 1, an is decreasing. An is decreasing. And so, let me remove all of this. And so we have shown that an is decreasing whenever n is greater than 1, which is the case for every single n except 1, right? So we know here, given that an is constantly decreasing, so let me move this here. So this means that an is monotonic, because n is going to go 1, 2, 3, 4, 5, 6, 7, so on, and it is the case that n is greater than 1 for all of these values, so an is going to always be decreasing. An is monotonic and decreasing. Okay, so if an is decreasing, it means that the highest value is going to be the first, right? Because the second, a2 is going to be smaller than a1, a3 is going to be smaller than a2, and so on and so forth. So a1 is going to be equal to 1 divided by 1 plus 1. That's going to be 1 over 2. So this is actually the biggest possible value for an, right? Everything afterwards is going to be smaller than 2. So we know that an is definitely less than or equal to 1/2. And now, since an is decreasing, it means that it keeps getting smaller and smaller and smaller and smaller. So we have to take the limit of an as n goes to infinity and see what happens at the very tail of the sequence. So we're going to take the limit as n goes to infinity of n over n squared plus 1. And if we take this, this is going to be infinity over infinity. So what we're going to do is we're going to divide the top and the bottom by n. So times 1 over n, and then times 1 over n. And the reason that we do this is so that we can get a nice number on top. So this is going to be the limit as n approaches infinity. N divided by n is 1 over n squared divided by n is n plus 1 over n. And so if we take this limit over here, that is going to give us, let's see, 1 divided by, the first one's going to go to infinity, right? And is n and goes to infinity. And the second, 1 over n, that is going to give us 0. So this is going to be 1 over infinity, which is 0, right? And so we can see here that the limit, as n gets larger and larger, it goes to 0. So we can say that an is definitely going to be greater than or equal to 0. It doesn't get smaller than that. So we can say that an is bounded. And that is it for number 77.